First of all, thank you so much to the audience for sending in questions. And I have to admit, I have a couple of, I'm not going to call them assistants because they're more than that, but they are going through all the Slido questions and helping me in picking out the most relevant ones. And I've seen things have been changing along the 5 presentations that we've heard. So, and also there's a tiny challenge with this panel because you are sort of representing different parts. Oh, that's too bad, Volker, you lost your name sign. Well, okay, no problem. One of the experts here. There's a challenge because you do represent different parts of value chains in plural. So trying to get you to talk together, we'll see how we can do this. But one thing I noticed is that everyone says, we need more power. And thank you and amen to that. And that means also that this is going to be a rather Eurocentric discussion, I believe, in relation to what we've discussed earlier. It's interesting as well to see. But several of you do also agree that we need to speed up the transition. And I would like to know, Magnus, when we were listening to your presentation, you were a bit worried. Do we have alternatives to, for instance, the hydrogen if that fails? It's not really well connected, is it? I mean, everyone wants more power, we want more speed, but do we have the alternatives if things should fail and we're getting more and more vulnerable? It seems like a tricky challenge.
Yes, it is a tricky challenge, and what's difficult is to, is to align the 2050 goals and the energy model scenario outputs with, where we are now and how to get there. And to get everything in place, we need to suddenly we need to produce 10 billions or million tons of hydrogen in 5 years in order to make the scenarios for 2050 to work. And that's not feasible. We know that. So we need to, while working on some like the main scenarios, like doing more R&D development, commercialization of hydrogen technologies, we are still, I use that as an example because we are still so far back compared to where we have thought we were many years ago. So it is good to try to explore also alternative scenarios. By that meaning, how much can we electrify? What are the potential of other e-fuels? Now, how can we supply more, how clean can our fossils be? What is the role of nuclear in combination with wind and solar, and so forth. So, it is difficult.
And also to choose the right energy source for the right use, I guess.
Definitively. So, and that is to not waste energy. So we need both to decarbonize the electricity use that we have now in Europe and we need to convert from fossil energy carriers to electricity and others. And that's also a challenge with other clean energy carriers, is that they are very energy intensive to produce, which means, so for instance, a hydrogen car that needs 3 times more windmills than an electric car. So if you can manage to drive electric, you save some area.
Yeah. That's good. Hege, you were actually putting your finger up. You wanted to comment on something that Magnus said?
Yeah.
Yeah.
Because I think what the past years have, what we have experienced and what we have learned is really that it takes time to build new value chains. And I think in the meantime, while we're building these value chains and getting things in place, I think it's very important for us to look at flexibility. Because stepping up on flexibility might reduce the consumption overall, and hopefully it will. And it also gives more predictability of many sources entering into the same system. We see some companies really stepping up on this area. And that's everything from getting consumer behaviors to change, to large industrials to change. But I think this is going to be important in the short term. And then I do believe that we will have to rely upon gas and LNG for longer and way longer than we anticipated only a few years back.
So since you mentioned gas, because I would like to continue on the flexibility path, but since you mentioned gas, there are a couple of questions for you specifically, Hege, and Equinor from the audience. Is CCS just an excuse to release more GHG emissions? And is it slowing down the energy transition, prolonging the petroleum era?
CCS is not focused predominantly on the oil and gas industry. It's focused on hard-to-abate industries. So there's no direct correlation towards those two. I think many of those industries need to be able to lower their CO2 emissions. And that's, of course, less expensive than to store it. But at the same time, it's very hard. So for me, no direct correlation. So basically, this is for other hard-to-abate industries predominantly.
But talking about hard to abate, there's another question. What factors made Equinor opt in for electrification of Melkøya instead of using CCS to cut CO2 emissions?
There's always many factors to look into when doing these calculations. And I think what we found the most efficient in all different manners was electrification.
Okay. So it's always consideration of different factors, and CCS is off the table for Melkøya in total. Okay. Kristin, I think you wanted to comment on the CCS topic?
Yeah. So as a hard-to-abate industry, we have as our first and foremost priority to mitigate the emissions that we have. But we do have 5 plants in Norway. They have been well invested. They have been there for 50 to 100 years. And if we're going to continue to run them, we're going to need CCS. So CCS or capture is then the second priority after mitigation. And finally, CCS usually doesn't take 100% of the emissions, maybe take 80, 90, and then you're going to need removals too. So I'm just saying there's a hierarchy, and we need all of them to be able to retain industry in Europe.
Now we're going to go into flexibility. And Hege mentioned it briefly, but Ingeborg, I think maybe you're the closest one to talk and to give us a definition on flexibility, because flexibility could mean different things. It could be flexible use of the transmission grid. It could also be flexibility in the demand side, flexible production and consumption. Could you just clarify these things for us, please?
I think it's both. Actually, we talk about flexibility both on the production side and on the consumption side. And then if you talk about the consumptions, and I don't necessarily think it means that we will not need more capacity, but it might lower the growth. That's for sure. So I think there's something that kind of across all the industries and across both production and consumption is something that I think we are eager to look into it. When it comes to consumption side, we have what we call the conditional, say connection, right? With the large customers. I think Hege, you're a good example of that. Also Equinor, where when it's possible to actually to have flexibility in the need, in the consumption, it means then that of course then it's easier to support that. Also, and I think that kind of flexibility we see with the big customers we already have, but we need to, I would say, industrialize the process so we can take it out more. And then again means that we are utilizing, I would say, the grid, the power system that we have much better.
Does that mean that you don't have to reinforce it and build more?
I would say we don't need to build that much more, or we are also saving time, because again, it takes, some of this kind of a big project, we're talking about 10 years plus. But we are also, I would say, testing out more on a kind of research and development, how can we take that flexibility all the way down to the consumer level, right? To look at, we're working with flexibility registers and see how we can utilize that. And I think also more in the short term, the available capacity is different from where you are in the country. So also there might be, consumption needs where there is a flexibility in where to build it, where you don't need necessarily to be in that geographical space, but you can be in another one. That's more short term. But I think all of these are different ways of utilizing what we have to the brim.
Magnus?
Yes, we have been studying recently some potential in Norway for industrial flexibility, also from present industries and decarbonized. And I think that the technical economic potential is quite huge, and it can make a big difference. Also explore that it's also about, but the industries themselves then need to focus on it and decide, because you are of course focused on optimizing the production of your goods, not kind of optimized to help the grid. So there is but with competence there is a potential there. But for at least in the Norwegian case, I'm much more worried about consumer flexibility, because in research centers in LD, we've been working for like 8 years and more of how to utilize household flexibility. And then in one political speech, all that seemed dead by our Prime Minister, promising cheap fixed electricity prices. So there is a bit of a difference between what can be done and what it seems like people want.
And actually, speaking of that fixed price, Ingeborg, this must be a trending question. So let's see if you feel that you can answer it. What do Statnett think about Norgespris? So that's the name of the fixed price. How does Norgespris impact the Nordic power market? What do you think, Ingeborg?
You had to ask that question, right? I think at the present, Statnett is not having too firm opinions about it. We are looking into that and understanding, what impact it could have. So I think this is still kind of in a very early phase. So we don't know all the technicalities on how it's going to be set up. But I would say the kind of it doesn't look like it's being earth-shattering in any way, but I think it's way too early to have any kind of firm statements on that.
Okay. But another thing that I would like to ask you about is the fact that you mentioned it briefly in your presentation, that you have to take nature into consideration as well when you are building new power lines, because we do have a nature agreement as well with certain commitments in it. So how do you balance the need for scaling up the transmission capacity with preserving and restoring nature?
Yeah, I think what we do see is, of course, that when we are now making our area plans, I would say the kind of the consideration to impact on nature is a very integral part of that. It's also a very integral part of the more local discussions we have when it comes to the specific projects. What I also see is a kind of a very positive development is that we need to be very fact-based when we do this. We need to know exactly what kind of, where are we? What is the kind of the characteristics of the nature that might be impacted? How can we use methods that are as little impacting as possible? For example, not building roads, but more these kind of things. But in the end, it also comes down to being sure that we have the right dialogue with the right, group of stakeholders in that discussion. But it's, but I do see that this being much more, I would say, scientific when we are actually planning and really making sure that we are limiting the impact. But I do think it's also very important that there is impact. There is some very, very challenging dilemmas here. As I said, we are building next to somebody, we are building in nature, and that is not something that we can eliminate, but we can do whatever we can to, say, minimize the impact.
Hans, you've been quiet so far. You've been talking about recycling, and I was just wondering, do we know what the potential is? You mentioned stockpiling, but do we know how much resources are just lying around in Europe?
So actually at present, I don't think that we exactly know it. But I think this is no problem at all. I think we should a little bit reconsider how it was, let's say, in the development of PV and the wind industry. So also in the 90s, so on our institute, we also started trying to estimate, let's say, the potential and the corresponding integration costs, so depending on the different sites. So this, let's say, so kind of supply curves that we try to identify it and to fix it. And I think here in the recycling business, we can use many metaphors from there. Also, when, let's say, setting, or like the European Union now has done, setting these 2030 benchmarks, so for extracting, processing, and so on. So we need numbers, we need a goal, and then we should think about how to approach it. So like, let's say, certain shares of PV penetration, wind penetration, and so on we had. And I think we should rely on similar kind of instruments, and we should incentivize, of course, let's say, this ramping up.
Because there's no infrastructure for this.
There is no infrastructure, and financial support. So like it was called feed-in tariffs, quota, certificate schemes, and so on, and later on more market-oriented instruments like contracts for differences now in the renewable business. But I think we also should now follow up after setting these targets, 2030, and in the Industrial Act and so on, the recycling, let's say, shares we'd like to reach. Also to think about how to reward, let's say, the first movers. And I think this is should be on top of the agenda of policy making. Because we also saw in the last slide, so I went through rather fast. So at the very beginning, we have, of course, very low learning rates of these technologies. But if we then double capacity and quadruple and so on, so they go significantly down. And again, a success story is the solar PV technology. So the learning rates, how they went down. So this similar things, I think, could happen then in the recycling industry, because we need to recycle then in the longer term high shares, let's say, of the existing, the mining-based ones, enriched, of course, with imports and own mining in the footprint of Europe. And we also should, let's say, in the processing stage then, because if we have minerals in Europe and at present, for instance, to refine them, we send them to China, and then we are again 100% dependent on a, let's say, a mineral or raw material we originally extracted from Europe. So this is no, let's say, local value chain. So in my
and going circular from a linear economy is not done in a day. Yeah. There are actually two speakers wanting to comment on that. So Kristin first, and then Hege.
Yeah, aluminium is slightly more mature as a recycled material than these materials, but Hydro is also involved in EV battery recycling, and we've seen quite a few issues with the regulations to get that started. But I just wanted to mention that in Europe, what we see with aluminium scrap is that over 1 million tons of aluminium scrap is leaving Europe every year, because it's cheaper to hand sort it in India and Malaysia and countries like that. So we need also develop technologies to be able to get the different fractions away from each other, but not least we need regulations so that when you do scrap a car, you don't just crunch it all together and then you have to pick it apart again. You need to be able to pick the different metals apart in an easy way. So this is about the design principles behind different end products.
Yes, so this is exactly, so the regulations must be clear, and they should, let's say, incentivize the fast ramping up, and not to to have too long lead times. But the European Commission now, I think, really understood it with these different acts, and they want to ramp up very, very fast. And I think this is important, yeah. And it must take place in a stable regulatory environment. Because you must trust. Because if you have regulatory risk that things change all 2-3 years, so no bigger company, no startup will, let's say, rely on that environment, and nothing changes.
Hege, you wanted to comment as well?
Yeah, I just wanted to comment on specifically lithium. You had it up there as well, but we have invested in one company in Europe, and we have also invested into 2 projects in the US. And this is given new technology, which is direct lithium extractions from brines, which is both more efficient when it comes to first production, but also less costly and environmental friendly as well. And I think this is a very good example, but still we see that everything needs to go to China to be processed, and then you get the CO2 footprint on that part as well. So there's something about thinking through how to build the whole value chain. And this is, I think, quite mature discussions in the US, still to be matured, I would say, in Europe.
Yeah. So maybe just one additional sentence. So here I think in Portugal and Spain, for the processing and refining, so there are projects planned already within this list to, let's say, also learn and to establish this process step in Europe again. Yeah.
I'm looking at the expert panel because they are getting eager to ask some questions and comments. And I think that Franziska Holz has been waiting the longest. Your expertise is within European and international markets of natural gas, coal, and hydrogen. You are an adjunct professor and contributor to the NTNU Energy Transition Initiative, and you are located in Berlin, in Germany, at the German Institute for Economic Research. So go ahead, Franziska.
Yeah, thank you. And thanks for this very broad picture of future value chains and energy system. I found that very curious that you included CCS, and I had a question about CCS. Hege, you said to roll out the technology, we need to bring down costs, and you mentioned transport, but you mentioned ships. And what we see in academic modeling is that we're modeling pipeline transport. So I wonder if that is also an option for you. If, for example, we could think about converting one of the gas pipelines from Norway to Germany to a CO2 pipeline and bring CO2 emissions from German manufacturing to Norway.
Yeah, we are looking into pipelines as an option, Central Europe. So highway to Europe for CO2, or the other way around, you might say. And then I think it's all about bringing down cost in every step of the way, given that it requires significant subsidies as of today. So pipeline dimensioning, of course, reservoir modeling, everything when it comes to barriers in reservoirs, where we're looking at natural barriers. And I was also mentioning briefly earlier on that we are looking into a concept now where we can directly inject from the vessels instead of having to go through a terminal and having a terminal on the spot. So we are really doubling down on each and one of the steps. And then the capturing cost we have seen increasing. And it's quite high as we see it today. So that's also an area where we need the industry to engage, even though that's not our focus area. We see that that's a prerequisite for that to come down to really build the industry faster.
Thank you. So next, I think Mark O'Malley, do you have your sign up? I think. You're a professor of power systems at the Imperial College London. Go ahead.
Okay, thank you. So I agree that this is a very broad panel and it's very difficult to ask just one question. So I've tried to frame one question and get it all into one question if I could.
So
I just want to make
the entire panel then?
yeah, the entire panel.
Yeah.
So, I think the Magnus started off very well, with his trilemma, and he ended brilliantly because, in fact, it's not a trilemma, it's a quadrilemma because it's the consumer as well. I think we always should. So fair play to you, because I was going to ask that question, but you included it. But my question really is about the consumer. And to Helge, you mentioned digitization, and you're going to make the system more reliable. Is that correct? That's a stupid thing to do, though. And it's a stupid thing to do because one of the problems we have in the power industry today is that it is so reliable that our ability to sort of say to people that maybe it might be a little bit less reliable, but of no impact to their life whatsoever. So we've made people expect this level of reliability that's not actually necessary for most things in life. And if we keep on making it more reliable, we all know about capacity expansion, as Magnus does, it adds enormous cost. So in fact, I think we need to be very clever about what we do. We need to educate them maybe that in the future, the service will be just as good, but the actual reliability of the power system may be less. I think it's very important. And I think the real danger of all these things is that once you bring in digitization, and you did say digitization will improve things slightly, but at the end of the day, you have to build transmission. The problem is then you get people in the AI business who are telling people like me and all the rest of it, AI will solve everything. Now, we all know that's bullshit, right? But at the same time, the general public believe it. So my question for the panel, and then, sorry, I have to bring this in. Your fixed price thing is complete nonsense. I mean, we all know that.
I guess we should.
You were very diplomatic in how you answered that, in fairness. We're taking it on board. That's a classic answer. But my question for the panel then is, how do we combat this? How do we combat this knowledge, real knowledge gap that's there? That people, like the AI people, will exploit it to their own good. They'll claim AI will solve. I'm sure you've had people come into Statnett and say AI will solve everything, correct? Am I right?
Not really.
No?
I'll answer properly when you're finished.
But how do we address this knowledge gap? That's what I want to know, because it is essentially a fundamental scientific knowledge gap. If we did not have this knowledge gap of science, life would be much easier for us, yeah? If Magnus and me were in charge, all would be good.
Right, who would like to start? Ingeborg first.
I guess I feel, compelled because I was so lucky that I came after you. And you explained 4 factors which are kind of making life more difficult for us. And you're a professor in energy systems, and I think that if you just look at the fact that the energy mix is changing, we are seeing that the weather is getting increasingly more difficult. There are all the 4 factors that you mentioned is something that for us to keep up the reliability of the network, we need to put in a huge effort. And I don't think that's stupid. I think
what I'm saying is do not make it more reliable. Because if you make it more reliable, it's going to be more costly to maintain that. Our problem at the moment is, if you look at it, most 99.9% of the people in the world do not need in any way, for any form of life expectation or any form of comfort, to have more reliable electricity. It's actually too reliable for them. There are certain things that need reliability. We need to educate the society that they're actually receiving a service that's way too reliable, that there's no need for whatsoever. But if you say to the politicians are going to make it less reliable, all hell breaks loose. So I'm not saying you're stupid. I'm saying what you are is you are feeding into a narrative that's wrong. It's wrong to keep on making, particularly in Norway. Now, in other places of the world, in Africa, for example, sure, there we need to make it more reliable, but not in Western Europe.
But it could be then that what I should take from the question is that in order to explain what it will take to keep the level we have, that's actually a huge demand to do. And I think that there's each of the 4 different factors are driving in that direction.
Or to prepare people that they have to live with several power outages and not the same stability. I mean, I'm not that old, but I remember in wintertime that we didn't always have electricity available. And we were used to that, because there were always trees falling over the power lines and there were storms and so on, which will increase, of course, in the years to come as well, making the entire grid more vulnerable.
But that is still happening in Norway quite a lot. And I think if we live in the north of Norway, and it's just 2 weeks back, we had 2 huge avalanches that caused outage. And it's more happening in the regional networks. And of course, if we need to make sure that the big transmission networks is holding up so that the impact is not as big. But it's still, we are living in a country with a lot of weather.
But his question is how to combat the knowledge gap. Are we too complacent in our European energy system?
Asking me now?
Well, I'm asking all of you, whoever wants to reply. Magnus?
I will say that in Norway, well, okay, maybe the knowledge gap has become larger, but I would maybe not say it like that. I would more say that the reality description is becoming, more diverse when it comes to what's needed, because now it's very easy to accept that yes, we can have cheap electricity without any new power generation and any new power lines or any trade of electricity, because a politician can just say 40 euro per megawatt hour, that's what you get, and don't think about it. And so I'm afraid that the gap between what we advise from science and also from operations is never been further away from the political reality when it comes to electricity consumption. I have to say that. I was in Bergen yesterday. We are part of a climate advisory group, handing over climate advice to the government. And one of the, I think, quite clear messages there was get rid of this Norges pris, the fixed price. So at least we try to say something, but I'm not sure.
Keep on talking, that's what I'm saying, and keep talking about energy efficiency, etc., etc. Did anyone else want to comment? Oh, yeah, okay. Hans?
Yeah, so maybe, Mark, maybe technologies like electric vehicles. So this might also be some kind of trigger technologies that, let's say, society and wider groups of people get more familiar with electricity, because you can't see it, you can't smell it, and so on. It's very difficult for non-experts, let's say, to understand and to get familiar with electricity. But now, with electric vehicles, if they see they can drive a few hundred kilometers, and maybe the Annexi threat will, let's say, be reversed. Maybe in 10 years you can drive more than or you can drive 1,000 kilometers. Then people see, okay, electricity somehow is a myth, but it works. And combined with your cell phone and with the IT and so on, so a wider society, let's say, accepts, let's say, technological, let's say, development, improvements, and digitalization. So maybe this could at least support or help to close a little bit the gap.
Yeah. Ingeborg, final note on this?
I just think it's actually the realization that there is a trilemma, or even the quadrilemma, I can't even pronounce it. I think that realization is at the core. There is no perfect answer here with 2 lines under it. And I think that's what makes this so difficult in the debate as well. And I think that if you can close the knowledge, say the gap on that, and understand that we have this, and I think we heard it also from the earlier session as well, there are some really, really difficult dilemmas here to discuss.
Thank you so far for that question. Mark, if you've finished, you can flop your sign back down again. And Volker Krey, I think I would like to hear from you now. You are Deputy Program Director of the Energy Program at the International Institute for Applied System Analysis, the IASA. And your specialty is integrated assessment modeling. So what do you want to challenge them with?
Yeah, thank you. I'm afraid my question is not going to be as entertaining as Mark's, but let me still try. I wanted to come back to the recycling topic, specifically on the case of aluminum. Kristin had alluded on that a lot of aluminum that was ever produced is still in use. My impression is we're in reality talking more about downcycling compared to recycling. There are different qualities of aluminum, and at the moment, that's at least my understanding, a lot of aluminum basically ends up, recycled aluminum ends up as cast aluminum in internal combustion engine blocks. Now, from what I've seen today, these are probably going to go away, or at least significantly lower demand will be there for this basically sink of aluminum at the end of life. So I was wondering, what is the industry response to that in terms of what to do? I mean, do you have strategies to upgrade the aluminum again? Other products in mind where this kind of lower quality aluminum could still provide useful services?
Yeah, thank you. Thank you for the opportunity to talking about this. First of all, demand is not going down for cast products because we have this thing now coming into the EV industry called mega castings. So you actually use more aluminum and you cast larger parts. So we're actually seeing an increase in the need for secondary foundry alloys, as we call them. But apart from that, yes, that would be downgrading or downcycling. So what we are doing and what the industry is doing is investing more in advanced sorting technology. So we have invested in a technology, it's laser-induced spectop. I'm forgetting, I'm looking at my Hydro colleagues. LIBS technology that we have patented and built. And this uses lasers to then sort out fractions of aluminum so that you can even sort it on the alloys. And that means that we can then keep the sort of softer alloys that are the finer varieties separate and put them into high-grade products. And so we're rolling out this technology now, both in Europe and in the US with investments, both places. And that's also a way to combat this export of scrap that's going to be hand-sorted by cheaper workers in countries like India and other Asian countries. So that's one area, but I think 80% of aluminum that has ever been produced is still in use. And if you have better regulations so that you can keep the fractions apart rather than just smashing a car together, then making it into shreds, and then you have to pick out the copper and the plastic, and everything has to be picked out. Just design the car so that you can lift off the aluminium part, and then you lift off the different parts, and then we have a completely different system. So we need to move up the waste pyramid in a way, and look at the design part.
Yeah. Thank you. I would like to move on because we are nearly running out of time, and there are a couple of more questions from the experts. Maria Amparo Alonso Betanzos, you are professor in computer science and artificial intelligence at the CITIC University of A Coruña in Spain. And you are also a professor too here at NTNU. So are we going to hear about data centers now?
No, I was going to answer Mark a little bit because he mentioned about artificial intelligence, and so none of the speakers told us about the use of this technology in their fields. I imagine artificial intelligence can help, but of course it is not something that can do anything, as Mark said. And on the other way, I want to say that we are also struggling in artificial intelligence with reducing our footprint. Yeah. Because, and that's one of the things that's going on this geopolitical situation also, is that in the USA, the energy is much cheaper, so they don't care how much energy they use for their calculations and things, and they are talking about creating this mini nuclear power so they can feed they can refrigerate the data centers that more or less just one company can use like
more than 5 times the quantity of water that we use in Spain, for example, in the whole year, just to train ChatGPT, for example. And I wanted to ask them how they see the help that this technology can come to whatever their energy fields, because I'm curious.
Yeah. Hege first and then Ingeborg.
Okay.
Yep.
So we are using, I would say, industrial or operational AI to a large extent, meaning deep learning, machine learning algorithms, etc. So really across the value chain within, we are using that technology. And I think where we have still step-ups to do is more on Gen AI. I think there are great opportunities there as well, but more in line of efficiency and energy, not energy, but information availability. So we have done some simple approaches so far. For instance, we have a drill bot where you can chat with a senior driller wherever you need it, with all the historical information gathered within. But still a way to go in this space, I think. And that's the area that will really drive energy consumption. And I think I'm not going to be too generic and speak for everyone, but I think everyone is in a somewhat early phase here. So in a few years' time, we will see the energy consumption really hitting the AI industry. A couple of weeks back, it was Sarah Week in the US, and the main topic was the AI battle in between the West and East. And it was all about energy affordability and energy availability to win that battle. Yeah, so that's of interest as a separate topic, I think.
Yeah. Just one thing.
Just a small comment, because we're actually
yes, a small comment. One of the things that we are doing in our universities, every time that we produce a new algorithm, we do not only measure the improvements in accuracy or any other reliability measure, but also in CO2 equivalent emissions. So it's something that can be used in the energy field also, and see how technology can help you, but showing how you can lower your emissions in that way.
Yeah. It's going to be interesting to see how AI can sort of help the transition instead of using more and more energy. I'm afraid time has run out for us, because I wanted you to have a final say, but there's no time for it. So instead, you will have to talk with the audience during the break. So I would like to thank Kristin Karlstad, Hans Auer, Hege Skryseth, Ingeborg Øfsthus, and Magnus Korpås for giving us some very useful insights into the energy value chains and the security issues. So thank you so much to you.